The next probability rule is the multiplication rule. We use the multiplication rule when we're looking for and probabilities. So for example, the probability of A and B, which we annotate with the intersection symbol over here, is equal to the probability of A given B times the probability of B. Meaning we first find the probability of B happening, and then we're going to find the probability of A given that B already happened, and then we multiply that. By the way, sometimes we may have the conditional probability given of B given A. So then we can also say that the probability of A and B is equal to the probability of B given A times the probability of A. This is closely related to that conditional probability formula. Remember, the probability of A given B was just equal to the probability of A and B divided by the probability of B. So really this is just algebra, moving the terms around. And so the and probability, you're always going to think of multiplication, where or probability, you're going to think of addition. And over here, when we have conditional events, we have to use the conditional probability and multiply it times the probability of the first event. Now this probability simplifies a little bit when we have independent event, as we will see below. So when we have independent event, we can simply multiply the probability of A times the probability of B. We will watch a short video in class that really describes these concepts really well. So let's look real quick at exercise 4 and exercise 5 over here. The first one being using our conditional events because we have dependent events. Exercise 4 states, in a sample of dog owners, 60% adopted their dogs. Of the adopted dogs, 78% were mutts. Remember, off was always a keyword for conditional probability. So let's write down what we have. So let's say probability of A means A for adopted. Probability of A is 0.6. And then we'll call it M for mutts. And over here it says of the adopted dogs over here. So given that the dog is adopted, right, whatever the conditional part is, that's always going to go behind the slash. We know that 78% are mutts. So this is the probability of mutt given adopted. And we know that's equal to 0.78. So make sure when you're finding these conditional probabilities, you have to make sure you're putting the correct event in front and the correct event in the back. So behind the slash goes the conditional event. In front is the probability we're looking for, like 70% were mutts. Assume 65% of all dogs are mutts. Okay, so that's our third event. So the probability of M is equal to 0.65. What is the probability that a randomly selected dog will be adopted and a mutt? So we are looking for the probability of A and M. And we know we have to use the conditional probability, and over here we actually have mutt given adopted, right? That was M given A, and then we're going to multiply times whatever came behind the slash, that's times the probability of A. And over here, we had additional information given with a probability of M, so we want to make sure that we're using the correct probability. All right, now I zoomed in, or zoomed out a little bit, just so I have everything on the page. So the probability of M given A was 0.78. The probability of A was 0.6. We are going to multiply those together, and we end up with a probability of 0.468. All right, the second example we're looking at, we're going to look at independent events over here. So when we have independent events, our probabilities simplify because we simply multiply over here. In the question, it says 20% of SDSU students take 119, 40% graduate in 4 years. If these events are independent, what's the probability that a randomly selected student has taken stats 119 or will graduate in 4 years? All right, we'll call the event that a probability student is taking stats, we're going to call that S. We're going to call the whether he graduates in 4 years G, and we are actually looking for the probability of S or G. So a little bit careful over here. Remember when we looked at the addition rule, when we're finding the union of two events, we have to add, or always means addition, and we're adding in such a way that nothing is counted twice. So we actually have to take out the duplicates, which is the probability of S and G. And we're using the fact over here that the two events are independent. That allows us to find the probability of S and G. So let's add these together. So we have the probability of S, which is, it says 20%, so that's 0.2. The probability of G is 40%, so that's 0.4. And then since it's independent, that means we can simply multiply. So this is the probability of S times the probability of G. So we're going to multiply 0.2 times 0.4. This is going to come up in an activity we're going to do in class. So keep that in mind. So we have 0.2 plus 0.6, plus 0.4 is 0.6, minus 0.08 gives us a total of 0.52. So how can we test for independence? Well, there's actually two tests we can do. So we saw two different probability rules before. And so the one probability rule is simply checking whether the probability of A and B is simply equal to the probability of A times probability of B. In a contingency table, that would mean we take our marginal probabilities, our totals in the last row or last column, and we're going to multiply and see if we get that joint probability inside the table. We can also use the conditional probability formula over here, looking at the fact that B already happened. Does that influence the probability of A? So either one of these is a good test for testing for independence. Depending on the scenario, one may be easier than the other, but we're going to look at both of them. Generally, it may be a little harder to find the conditional probability, so most people generally prefer the first method. Another thing to keep in mind when we're looking at probability, we're simply looking at, are these two the same? And if not, we're going to say that it's dependent. When we go into stats land later on and we're looking at our project, sometimes we may say, oh, it's very, very close. So it could be independent, especially when we're looking at sample data to describe our population data. So that's something to keep in mind for probability. We're simply looking, is it equal or not? If it's not equal, then we're going to say it's dependent. If it is equal, we're going to say it's independent. We'll do lots of activities regarding that in class.